All right, we're continuing on with the practice midterm exam. I'm going to start here with number 22. And as you can see right here, what they're looking at is trying to find out if you got the size of a regular pentagon, and the sizes are 12, each side is 12. They want to know that what was going to be if they lengthen each side by 8 times the original. So how many times larger that's going to be in the replica. We know that because this is a square area that we're looking at, one of the things I'd like to address, now granted we know that the formula for a pentagon is area equals 1/2 the aperture times the perimeter, and since we haven't gotten into trig yet, we won't be able to solve this, but we can solve it from a different way. In other words, if I have a square that is a 2 by 2, all right, then the area of that square is going to be 2 times 2 is going to be 4. If something that is 8 times larger, all right, which means 8 times 2 is going to be 16, and that's by 16, so that would be 256. And we know, just by using our little bit of math, that that's going to be 64 times larger. One of the ways to look at that is because each side is multiplied by 8. If we multiply 8 by 8, since it is a square area, then therefore the answer to this one here is going to be 64, which is I have indicated down here. Now next we have a shape here of a trapezoid, all right? And so they want to find out if they add the area of this trapezoid to this trapezoid right here, what will be the change in the dimensions of the original trapezoid? Well, the first thing is we know that the area of a trapezoid is 1/2 the height times the addition of the two bases, base 1 and base 2, which is 24. I canceled, the 2 will go into 24 2 times, multiply, that gets 96. Now, here they say add the area of 96, so I end up with 192. Well, if I go back and look through this right here, I know that if I double this, the height by 16, again, the 2 will go into the 24, so 16 times 90, since 16 times 12 is 92, therefore our answer right here is going to be A, all right, that the height is doubled. All right, let's shift over here to here. Again, we have the same thing. We have a rectangular flag at the sports, and I drew kind of a flag like this right here. And 4 times 6 divided by 2 is 12, and then 8 times 12 is going to be, divided by 2 is going to end up being 48, and that's an order of magnitude of 4 times. All right, 4 times to equal that. But we also know that since it says that we are doubling it, both the base and the height, then therefore that's going to be 2 times 2, which is going to be 4. All right, which is going to be our answer here. All right. Next one, we got 2 triangle beds. They want to add trash. Which statement is true? Well, first thing is we know this right here. We have an angle, side, angle, side. So these 2 triangles are congruent by AAS, or angle, side. If that's the case, then they would not have different areas. All right, the lengths would be the same. So that the answer is going to be the perimeter is the same. All right, let's shift over here to the next one. Now here we have a cylindrical body and a conical lid. So they're looking for the surface area. Yes, they want to know. They can put paper around it, so which means the surface area. All right. So what we got to remember here. So if we have the cylinder, all right, the cylinder right here, what we need to do with that cylinder is find the surface area of that cylinder without this base, without the top of it. And also for the cone, all right, for the cone that's coming down like this, we only need the lateral area of the cone to be able to work this, because this cone is going to sit right on top of that, all right? So the surface area cone without the base is nothing but the circumference, 1/2 times the circumference times whatever the slant length is, and the slant length is 2, and we know the radius of this thing is 2, so therefore we're talking about that the area of the surface area of the cone is going to be 4. Now we got a cylinder We have a cylinder without one of the bases, which means we take the area of one base rather than two bases, one base. Then now we take the area, we take the circumference times the height, and we put this into this formula right here, and we substitute in. We got the radius of 2, and we got the height of 3. So this is going to come out to be 12. So you add those together is 16. We take the 16 plus the 4, we get 20. So our answer is 20 pi. Now, we come here to a ball within the cylinder, and they tell us the diameter of this thing is 20, which means it's going to be 20 high, diameter of 10. So we're trying to find the maximum volume, which is going to be the volume to put into this cylinder. All right. So again, we have the base times the height of it, which the base is nothing but pi r squared, which is going to be pi 10 squared, which is 100, times 20. All right, and so we multiply that, and they have been using 3.14, so our answer is going to be right here of 6,280. Now, let's shift over here to the volume of these. These are solids, so that means that there are cubic measurements. So if we take the cube root of these two numbers, we'll get 11 and 9. Now, we'll take the square root, because notice right here, this is a square figure. So we take the square root of that, and we'll get 24.6. So now we put up a ratio of 11 to 9 as 24.6. We cross multiply and divide by 11, and we'll get 20 is essentially our measurement. And then all I have to do is square that, since we're looking for square meters, and we'll get that, and this is our answer here, okay? Now, we've got two pipes, two cylindrical pipes. You notice one of them is 5, and the other one they get us right here that the circumference of this one is 20 pi, which means that the radius of this one right here is 10, which essentially that is doubled. Now, here they're trying to find where'd it go? They're trying to find the volume. Oh, yeah, the volume of that, which means that's a cubed function. So now this would have been doubled. So I go 2 times 2 times 2, which is 8. So therefore, it's going to be 8 times larger. Next, we have a sand pit. I just drew here a little bit of a cube. All right, and we have the dimensions of this is 7 by 5, which is going to be 35 times the height right here. That gives us a total right here of, here we go, of 61.25 cube. Now we add 17.5 cubic feet of sand to that, and we will get this number right here. Now I take this cubic, divide it by how tall this thing was, which was the 1.75 feet, and that's going to give me 45. And of course, 45 can be a number right here is going to be 5 times 9, and 9 times 5 is going to be 45, so that is our answer. Okay? Next, we go to the next one right here is we have we're looking for the volume. We know that the volume of a pyramid is 1/3 the area of the base times the height, and we know that this base right here was 12. We got the 1/3, 12, and now the height, so this has got to be the answer. All right. Next one, we got a sphere that's enlarged, so the surface area is 9 times greater than the original. All right. So if it's 9 times greater, then we're going to have, and this right here is a surface area. That means we just take the square root of that, and that's going to be 3. All right. Okay. Now we've got two similar cans here. We're trying to find the surface area. So if these are similar, you got a 2 to 4, which is doubled. So this has got to be 3 to 6. So we're doubling that right there, and so therefore we cross multiply. So we're doubling. So all I do is now I take my 2 pi r h, and we double that in, and we end up with this answer here. Okay. This right here is a contrapositive. So what I did is, remember, contrapositive is the converse and inverse. So I move the hypothetical to the conclusion and the conclusion to the hypothetical and negate them, which means our only answer can be C. All right. Next, we go to next we go to here of a what's a valid conclusion, and this here and this is almost the same thing. If P then Q then R, therefore R then Q, and so this is the answer to this one here. All sergeants clear the fitness test, and we know that Harry did not do it, so therefore Harry is not a sergeant. All right. Now here we go. Here, now here all squares are parallelograms. We know that all of these two right here is that a rectangle will do that. The square, the diagonals are equal. All right, well the same thing as a rectangle. So this is the only one that talks about a parallelogram where the opposite sides are parallel. All right, and we're on the home stretch here. The next one right here, we got this right here is a kite. The key things that qualify a kite are condition 3, which means that this side and this side are congruent, this side and this side are congruent, all right, and that they the DE the diagonals do not are not. I'm sorry. Yes, the DE and these sides right here are not equal. All right, so that qualifies that as a kite. All right. Next, we go to 38. Here we got this right here where this line right here is parallel. All right. So this is a little tricky right here because this is saying that this side right here, that angle 1 and angle, angle B, this B right here are the same. All right. So that this triangle 1 and this triangle here are these two angles are here 1 and 2 are congruent because these are two parallel lines cut by transversal. Therefore, that's two triangles, this one right here and this one right here. All right, so therefore these are similar triangles. Next we go down here, is that here we're trying to find that these angles, what angle is going to be congruent to this angle right here, the ACQ, is that we know that this leg and this leg are the same. So I drew it out here this way to make it a little bit easier. All right, that this leg and this leg are the same, and this leg and this leg. All right, so therefore these two triangles are congruent. Therefore, this angle is going to be congruent to the ASB, which is this angle right up over here. Okay, and this is a step through a quadrilateral for turn the diagonals, and essentially this comes down here where you're using alternate interior angles to be able to prove that this right here is a parallelogram. As you notice right here, for here and here would be alternate interior angles. And our last one is here. I went ahead and positioned these right here, these different points, and these right here are all true right here, so he is correct that all sides are equal. Therefore, it's a rhombus, all right? And that takes care of that. Oh, yeah, the last one is that if this right here, we know this is the Pythagorean theorem because it's a right angle, a squared plus b squared equals c squared, and all that is saying that this square plus this square is going to equal to that square. And that is it.